Okay, so today we're going to talk about an ellipse, and an ellipse is an oval. It's kind of how the Earth travels the sun. People always think it travels in a circle. It doesn't. It travels in an oval shape. Okay, so there's two types of ellipses. The first type of ellipse is an oval. All right, and it has different parts. It has a center. It has two vertices on the long ends. It has co-vertices on the squished in or short ends. And then on the same axis that your vertices are on, it has two foci. And that's how an ellipse is made, is if you add up the distances from this foci to that foci, you add those two distances up, that distance will be the same all the way around to any point, okay? So your equation for this one would be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. It's important that's equal to 1. That's the key to this stuff, so make sure you keep track of that. Your center is still your h and k, just like it is basically everything else. Your vertex, your vertices now, are going to be h plus or minus a k. So you got to take the square root of the number underneath your x value. So you're basically looking for whichever number is larger. Because if the number is larger underneath x, it's going to be wider with the x. If the number is larger underneath y, it's going to be larger with the y. I'm going to show you that here in a second. Your co-vertices will be h, k, plus or minus b. And again, it will be the smaller of the two numbers. So if the b is underneath x, you'd be adding it to the x value of your center, and vice versa, okay? Your foci, since this is a squared plus b squared, is going to be a squared minus b squared is equal to c squared. And then c will be your foci, and your foci always goes the same way as your vertex. These two will always be the same. So this is going to be h plus or minus c k. All right. A always represents, I'll write that over here in black because this is really important. A, for both of these that I'm going to do, is the distance between center and vertex. So your larger of these two numbers is the distance between the center and the vertex. B is the distance between center and co-vertex. And C is the distance between center and foci. Okay, those are the three things you need to know. All right, now, you also have an ellipse that can go vertical. Okay, a vertical ellipse looks like that. It's still the same idea. Your center is still in the middle. You have vertices on either of the longer ends. You have co-vertices on the shorter ends. And you have foci in the middle. Okay, so the equation here is basically the same thing except your a and b are switched because your larger number is always a. So it's going to be x minus h squared over b squared plus y minus k squared over a squared is equal to 1. All right. Your center is still h and k. Your vertices now are h, k plus or minus a because your larger number, your a value is underneath your k value. Your co-vertice would be h plus or minus b, k. Your formula is still the same, a squared minus b squared is equal to c squared. And your foci, again, falls always with your vertex. So see how your vertex, you switch your k value? That's the same that you're going to switch down here. So it's going to be h, k, plus or minus c. Those are the formulas that you need to do this. I'm going to put on a couple of videos about how to work these problems out. Those are the formulas that you're going to graph. That's what you need to figure out. Okay?